Hello, everybody. My name is Claire, and I'm a high school student from Cary, North Carolina, who happens to geek out over anything to do with space. Today, we're interviewing Dr. Kathryn Stack Morgan, a scientist at NASA's Jet Propulsion Laboratory. Dr. Stack Morgan specializes in Martian sedimentary rock record, and she's currently working as the deputy project scientist of the Mars 2020 Perseverance mission. One of the purposes of this mission is to understand the evolution of the surface of Mars and to search for the evidence of possible life on this planet. You may have seen her recently on the 60 Minutes television show Interview. It's an honor to have you here, Dr. Stack Morgan.
Well, thank you so much for having me, Claire. I'm excited to be here.
Me too. All right, let's jump right into it. When did you know that you wanted to be a scientist, and did you ever expect to be working at NASA?
I think I wanted to be a lot of things growing up. I think like a lot of kids, and that changed, when I was really little. I think it was very much focused around my hobbies. So I played violin. I wanted to be a violinist. I liked ballet. I wanted to be a ballet dancer. But I think sometime around kind of late elementary school, early middle school, I discovered astronomy and stars, and I used to really enjoy going to planetariums with my class at school and with my parents. And I think around that time I started to realize that there were other careers out there in science, and so I think it was around then that I thought I really wanted to be a scientist. And I don't think I ever knew that I didn't really know about NASA at that point. So I don't think I even knew that that was something that I could do or go into. And I didn't know that NASA employed scientists. So that was something, as a kid, I just didn't know those things. And so I think I kind of fell into that as I went along in my education. So it was a surprise. I wish I could go back and tell my younger self, like, you'll be doing all these cool things. But at the time I didn't know. And so it's exciting to see where I've gotten, and I really enjoy what I do now.
Awesome. In your opinion, what traits or skills makes a great scientist?
So I think this is an easy one for me, because I think one of the most important things is to ask questions all the time, and to not be afraid of asking questions, because that's what science is all about. It's about asking questions and then trying to design a way or a method of answering those questions. And so just being the kind of person that when you hear something and if you're not sure about it, or you want to know more about it, to ask about it, and knowing that you won't necessarily always get an answer or the answer that you want to hear, but it starts the process of saying, okay, well, I'm learning more about something, and I want to learn more about it. And so I think asking questions is always the first thing I say when I think about that, because I think that's just fundamental to being a scientist, and not just accepting things because you hear them, but digging a little deeper and saying, okay, let me convince myself that I believe that. And that's a really core part of being a scientist.
Great. I love the Science Olympiad programs in my elementary school. What do you think we can do to promote more girls in science?
That's a really great question, and it's a hard one too. I think, unfortunately, there haven't been a lot of role models out there, I think, for young girls. And when I think back to when I was younger, I don't think I knew about any women scientists that I could look up to. And I know they were out there, but I just didn't have exposure to them. And so, now that I'm in the position that I'm in, I really enjoy doing outreach. And I didn't ever expect to be doing things like a television show, and I still get nervous when I do that kind of thing. But I like doing it now, because I know that maybe I have a chance to reach young girls out there who are thinking about this, or who didn't know that this was a thing that you could do. So, for me personally, that's something that I think of in my own work. But, I think doing the best we can to expose young women and young boys too, who also are a part of recognizing that women can also be scientists, and just making sure that we put, examples and role models in front of young children and say, you can do this, and you can be this too. And so I think that's a big part of it, is just helping to bridge that gap, especially for young girls who think, oh, I don't like science or I don't like math, but we're realizing that they don't have to feel that way and they can do it. So I think that's an important part of it.
So what evidence is leading to the theories that there was once life on Mars?
Yeah, that's a great question. And of course, we haven't yet found solid evidence for life on Mars. We haven't found alien life, but what we have found is evidence that Mars was once a habitable planet. And so that means that we think life once could have existed on the planet. It had all the basic building blocks that life needs to exist, at least life as we know it. And that's things like water, as well as some basic chemical elements and compounds that we know life needs, like carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. Those are kind of the main building blocks of life. And so we know that all of those things existed on Mars, as well as an energy source. So life needs energy to live. And, we use sun and we eat food and that type of thing. And microbes and other life needs that as well. So we know that all of those building blocks existed on Mars in the past, and that Mars might have once been a little bit more like Earth than it is today, or a lot more like Earth than it is today. It's a pretty barren place now, but we know in the past that it had water flowing on its surface, likely a thicker, probably warmer atmosphere. And so when we think about ancient Mars, we know that it probably looked a little bit more like Earth today, and it had all those building blocks. So anywhere that we have that on Earth, there's life. So we're pretty optimistic, I think, about having life on Mars because all of the building blocks and all the pieces were there. And it's just putting together that puzzle of life and then finding the evidence for it. So that's what we look for Mars, and that's why we're so excited about Mars as the place where life could once have existed.
So you said something about one of the main building blocks being flowing water on Mars. Do you think that if there were flowing rivers in the past on Mars, do you think it's possible that there are also oceans there too, or other big bodies of water?
Yeah, that's a great question, and that's been a question that's been circling around the Mars community for a long time, decades even. There's unlike Earth, Mars is very interesting in that it has there's a big difference between the northern hemisphere of the planet and the southern hemisphere of the planet. And we call the southern part the southern highlands, and it's kind of raised up above, and it's a plateau, and it's very old ancient terrain there. But the northern part of the planet we call the northern lowlands, and it's kind of lower in elevation. It's much smoother, much younger. And there's been a lot of speculation that the entire northern part of Mars could have once been covered in an ocean. But that's been a very controversial idea because that would be pretty radical. But there's been growing, I think, work that there were, if not an ocean, at least very large bodies of water in the northern part of Mars and also in craters around Mars. And we know that because we see certain landforms like deltas and alluvial fans, particularly the deltas, are evidence that standing bodies of water could have been there on the surface. And so we have a delta in Jezero crater where Perseverance is headed. And so that's one of the reasons why we're so excited about that landing site. So we do think now that there was a good chance that there were large bodies of water. Whether you decide to call it an ocean or not, I think it's up to you. But there is definitely speculation that there was a very large ocean on Mars once.
So if Perseverance was to find evidence that there was once life on Mars, how will this change NASA's projects and future priorities?
That is just a fantastic question because it's almost hard to imagine and hard to answer because we have a fantastic space program and a fantastic exploration program, but we haven't yet found evidence of life. So we go out there with optimism and we search for what we hope to find. But then there's always a question of what happens when you find it. I think if we were to find evidence for life on Mars, either on the surface with Perseverance or with the samples that we bring back, I think our focus would turn, back to Mars and say, okay, we have more exploration to do here. We need to understand how life evolved on this planet, because if we find it with Perseverance, that'll be one location on the surface of Mars where we found it. But Mars has a very long history, and a very long history that's preserved in the rocks on Mars. And so with that first exciting discovery, we'll have to go back and we'll have to learn more about it, and we'll have to go to more locations. So I can imagine, right now we are getting very excited about icy ocean worlds that exist further out into the solar system, like the moons of Jupiter and Saturn. And of course, that's still very exciting, and we should certainly still explore there. But I think if we find evidence for life, we'll likely turn our focus back towards the inner part of the solar system and send more missions to Mars and more sample return missions to Mars so that we can better understand how life evolved on that planet.
Now, I have two final questions. Perseverance is a very meaningful name, especially during the pandemic. Who comes up with the names for NASA's rovers and spacecraft?
Yeah, so this has been the case, I think, for the past several rover missions that we've had. I know certainly Curiosity as well as Spirit and Opportunity, but NASA runs with a commercial partner, runs a Name the Rover contest where young folks, K through 12, can submit a name and a short essay describing why they think that their name is the right one. And they run a big contest, and I think this time around we had, I think it was 28,000 entries or something like that. And so then judges read all of those essays and narrow it down, one essay at a time. And then finally, and actually I had the great pleasure to be involved in some of the later parts of the naming down selection. And so people from the project and from NASA get involved with that. And so we basically narrowed it down to a couple of finalists. There were 9 finalists, I believe. And then basically we go through the essays and meet the kids who wrote those essays, and then NASA headquarters makes the final selection. And so that's how we ended up with Perseverance.
Do you remember like any other of the names?
Yes, so I think in the final 9, there was, it's funny actually, I think the names kind of separated into 2 types of names. Some of the names like Perseverance, and I think others were tenacity, fortitude, courage, were names that really spoke to how difficult it is to operate a rover on Mars and to get a rover to Mars. And then there were other names on the list like vision, clarity, ingenuity. I think those are the ones that are coming to mind that kind of are maybe more optimistic or speak to what we hope to find and discover about Mars. And so I think those were kind of the 2 different categories that the names seem to fit in. But it turned out that I think picking one of those names that really speaks to the challenge of getting a rover to Mars is one that really spoke to NASA, and then in the end, I think has spoken to a lot of people as we've gone through the challenges the past couple of months. And so I think in the end, it turned out to be a great name for the rover, and one that when it was selected, I don't think we had any sense for how meaningful it would become to people.
Mm-hmm. As soon as I heard the 60 Minutes episode and they announced that it's going to be, the name of the rover was going to be Perseverance, it just felt really heartwarming. And so that decision was before COVID happened?
I think we announced the name, it was maybe just a week or 2, I think, before JPL shut down and sent us all home. So I think at that time, coronavirus had started and certainly was popping up in places, but it hadn't really, the full effect in the US hadn't come into play yet. And so I think there was no telling at that point when the name was selected how the next couple of months would go and what we would all go through. So at the time, we didn't know how it was going to be. So yeah, the Perseverance was selected largely before then. And it's just been really great to hear from people like yourself and others, how meaningful that name really is. And it's great to have, the public riding along with us and feeling like this is something really meaningful to them too. Of course, it is to us who work on it, but it's great to see that connection with folks outside of the mission too.
Yeah. Final question. Will Perseverance be taking another selfie once it lands on Mars, like Curiosity did?
Yeah, so fortunately, Perseverance does have a very similar camera to the camera that Curiosity used to take its selfie. Curiosity used the MAHLI camera, which is the Mars Hand Lens Imager, and that's located on the end of the arm. And Perseverance has nearly an identical camera on the end of its arm. It's called Watson, and it's part of the Sherlock instrument suite. And so we do expect that Watson will be able to take selfies of this rover too. I think another exciting possibility, Perseverance is bringing with it a helicopter, the Ingenuity helicopter. And there's been talk that perhaps we'll be able to snap a picture of the rover from the helicopter. And so that's not exactly a selfie, but that'll be another very unique and exciting perspective of the rover that I think just helps really connect people with the rover and really feel like they're standing there on Mars with it. So we'll hopefully have some really great images of Perseverance, both from the Watson camera and perhaps from Ingenuity.
That's amazing. Thank you so much for taking your time to be with us today, and good luck with your important work on Mars. Is there anything else you'd like to add to close the interview?
Well, I'll just say thank you a lot, Claire. I really enjoyed this, and thank you for having me. And yeah, I'm excited to maybe have you join us in a couple years when we get those samples back. Maybe it'll be your turn then. So thank you so much for having me, and I'll talk to you later.
Yeah, thank you for being here.
All right, bye.
Bye. If you enjoyed this week's Science House Express, please like and subscribe to our page to see more exciting news and fun activities. See you next time. Bye.